Good afternoon. Today we are going to see the shape function for CST element, and that is Cartesian coordinates. So CST element using Cartesian coordinate. So CST element means we know we have three nodes, that is primary triangular element we can say. So we have this 1, 2 and 3 noded triangular element. So now as we have this as 3 noded, so as we know Pascal's triangle, then Pascal's triangles, we have this will be 1, we have x and we have y. So therefore we have u is equal to alpha 1 plus alpha 2x plus alpha 3y. This is my displacement model for three-dimensional element. So x, y, because we have this as two-dimensional element. CST element we have two-dimensional element. So it is two-dimensional. So now similarly we can have v also, that is displacement in y direction. So now in this we can write this in matrix form. U is equal to 1 x y, which is alpha 1 alpha 2 alpha 3. Similarly we can have v, which will be alpha 4 alpha 5x plus alpha 6y. And then if I will write it in matrix form, then we have this as v equal to 1xy alpha 4 alpha 5 alpha 6. So we have, this is my displacement model for displacement in x direction, and for in y direction I have this as displacement model. Now as we have three nodes, so we have to put values of the coordinates at respective point. So now if I will consider this will be x1 y1, then I will get u1 that is equal to alpha 1 plus alpha 2 x1 plus alpha 3 y1, because we have at node 1 x equal to x1 and y is equal to y1. Similarly, I can write at 2 also, that is at 2 I have x equal to x2, I have y is equal to y2. So we are substituting these values in general displacement model in x direction. Then we have x3 y3 third node, and then we will get it as u3 alpha 1 plus alpha 2 x3 plus alpha 3 y3. Now I am considering only shape function for displacement in x direction. You can follow the same process and you can find shape functions for displacement in y direction. So now knowing this, I am in position to write it in matrix form. So we have this as u1, u2, u3. So we can write this as u1, u2, u3. And here I have alpha 1, alpha 2, alpha 3. So we have in first row alpha 1, 1, alpha 2, x1, alpha 3, y1. So this will be for u1, this will be for u2, and this will be for u3. So likewise, we will get this in matrix form. Now as we know, we have, if you will see the basic equation, we have this equation as 1, x and y. And then here I will get it as alpha 1, alpha 2, alpha 3. Now I have to replace this alpha 1, alpha 2, alpha 3 by u1, u2, u3. Because our shape function is the function which will give us displacement at any point with the help of or by using displacement at nodal points. And therefore, we have to replace this by u1, u2, u3. And for this one, if you will see this, then I will get it as alpha 1, alpha 2, alpha 3. And that is equal to, we have this matrix 1, x1, y1. We have 1, x2, y2. Then we have 1, x3, y3. And then we have inverse of this and multiply by, we have this as u1, u2, u3. Now to find this inverse, we have inverse. If I will write A inverse, that is equal to, if we will consider this as A, then we have A inverse equal to adjoint divided by determinant. Now how we will find adjoint? So adjoint we can have minus 1 m plus n into cofactors. So into, yes, into minus this will give us cofactor. And then what will be adjoint? So adjoint we have transpose of cofactors. So we have this as cofactor values, and transpose of this gives me adjoint. So first we have to find cofactor of each element. Knowing cofactor of each element, we have to make its transpose, and by making transpose, I will get adjoint, and A inverse is adjoint upon determinant. So now we are interested to find determinant first of this, and for this determinant, we are going to use area of this triangle. So we have one derivation. So just I will go a little bit fast. So let us consider this same triangle, and we have these as the coordinates. Now we are interested to find the area of the triangle, and we are going to relate that area of the triangle with the determinant value. So now we have, this will be triangle. I have taken these lines, and now I will consider first whole part. So I will consider this whole part, and from this whole part, I will subtract this part, so which is below the triangle. So we have to subtract this part which is below the triangle, and that will give me area of this triangle. So now we will calculate it. We will consider trapezoidal one by one. So first I will consider this trapezoidal, which will be A1. Now you can see this. So we have this trapezoidal, and we have this value, we have y1, we have this value y3, and then we have height, that will be x3 minus x1. So this distance, x3 minus x1. So we have x3 minus x1. So 1/2, we have summation of parallel side into height. So I will get area of this triangle as A1. Now knowing area of this triangle, I can move ahead. That is area of second triangle. So this will be A1. Now I will calculate this value A2. Now again I have this as y3. I have this as y2. And this distance I will get it as x2 minus x3. And then same 1/2 y3 plus y2 summation of parallel sides into x2 minus x3. This will be of second. And then we have to subtract this below, and that will give me area of the triangle, that is above. And then this will be, we have y1, this is y2. So we have this distance will be x2 minus x1. And if we will put this, I will get value of A3. So now to get value of area of triangle, we have to add A1 plus A2, and then from this we have to subtract A3. So then we will get this triangle value. So now we will calculate, so this triangle, that will be A1 plus A2 minus A3. Now I have calculated A1, we have this one. So A is A1 plus A2 minus A3. We have substituted this value of A1. Then we will substitute value of A2. And then we will substitute value of A3. So we have value of A3, that is equal to this value. So I have taken different colors. And now knowing these values, you can see we have this as y1 x1. Here we have minus. This minus minus becomes plus, gets cancelled. Then we have y2 x2 here plus, here minus into this plus. So this will get cancelled. and then we have y3, one term we have. Here we have y3 x3 plus, here we have y3 x3 minus. So this gets cancelled. And then we have 1, 2, 3, 4. Sorry, we have y1 x1. So we have y2 x2. So that also we have to cancel over here. y2 x2, y2 x2. Then we have y1 x1, we have to subtract this y1 x1. So 6 terms cancelled, and we have terms remained is 1, 2, 3, then we have 4, then we have 5, and then we have 6. So we will write these terms below. That is area of this, that is equal to. And then if we will go for this determinant, then the values we are going to get. So this is nothing but our value of the determinant. So now, therefore, means whatever value we are going to get, so I can say this value. This value is nothing but determinant. And therefore, I will put this bracket as determinant D, and substituting this, I will get determinant of this 1x1, y1, 1x2, y2, 1x3, y3 is equal to 2a. So this is most important equation which we require, because we know we have A inverse that is equal to adjoint upon determinant. And therefore we require now determinant is 2 into A. So now we will go with this. So we have just already, I have mentioned this. We have to get alpha 1, alpha 2, alpha 3, and from this we will get this value. So now we are interested with adjoint. So this is determinant we have calculated. And now you can see this. We have this as adjoint. Now how we will calculate this adjoint? So I already mentioned we have cofactor, and that is minus 1. So I have mentioned minus 1 m plus n into minor. That will gives me cofactor. Now you can see this. Suppose I will consider 1. So I have to remove this. I have to remove this. And then we have this will be my minor x2y3 minus x3y2. Now what is number of the element? So we have a11. So we have 1 plus 1, 2. So if I will put here minus 2, minus 1 to the power 2, so we will get this value as plus. So whenever you have addition of this row and column is even, my cofactor will be plus. And when addition of column and row is odd, then I will get that cofactor as minus. So likewise, we have to calculate this value. Now suppose I will consider in between any values, I will consider cofactor for this x2. So we have to remove this, we have to remove this. Then what we will get? We will get this will be y3, 1 into y3 minus 1 into y1. Now what will be element number? So we have second row, and then we have this as second column. So 2 plus 2, 4. So y3 minus y1. So you can see this value. Now if we will go, so this even we have considered, now I will consider one odd. So let us, we will go y2. Or now third, y3. Suppose we will go for y3. But this will be 3 and 3, 6. So I will go x3. So now x3. And then what we will go? Y2 minus y1. So we have minor is y2 minus y1. And then we have minus 1 to the power. So we have this as 3 and 2. So 3 plus 2, 5. So minus 1 to the power 5. So minus y2 minus y1. And if I will take minus inside, we have y1 minus y2. And you can check it, we have this as y1 minus y2, which will be my a32. So likewise, we have to find and transpose of this and divided. Already we have for this 2a, this will give me inverse. So transpose upon 2a, that will be inverse. So actually here we should have this u1, u2, u3, u1, u2 and u3. So now knowing this alpha 1, alpha 2, alpha 3, and substituting this value, because it is difficult to write every time this value x2 minus y x3 y2. So likewise, so we will have this value will be considered as a1, this will be a2 and a3. Similarly, these values as b1 b2 b3 and c1 c2 c3. Now substituting these values, we will get this alpha 1 alpha 2 alpha 3 in this fashion, that is a1 a2 a3 b1 b2 b3 and c1 c2 c3 u1 u2 u3. Now transpose, by transposing we are going to make or consider this row as column and this column as row. So you can see this, we have a1 a2 a3, this column will becomes this row, then b1 b2 b3 becomes row and c1 c2 c3 becomes row. So this total is my a inverse. So this is value of A inverse. Now we will put this value of alpha 1, alpha 2, alpha 3 in the basic equation of U in this equation. U is 1xy, alpha 1, alpha 2, alpha 3. By substituting this value, we will get it as 1xy, xy 1 upon 2a and these all values. Now we will rearrange. We will multiply this with this, then same row with this and same row with this. And 2a we are already determinant of this. And from this I will get, because you can see this 1 into a1 plus b1x plus c1y upon 2a. Similarly, a2 plus b2x plus c2y, and likewise for third. So now this part we are going to consider as n1, that is shape factor for node 1. This we will consider n2, which is shape factor for node 2. And this I will consider n3, which will be shape factor for node 3. So by using these values of shape function, we can find displacement at any point. So we have, this will be u equal to n1, n2, n3, u1, u2, u3. So now this will be my value of u1, n1, this will be n2, and this will be n3. So now if I will write it in short form, then I have u is equal to n into delta. So likewise, we are in position to find the shape function for different element with different nodes. So now we will stop here only for CST element. Civil Engineers Technical Hub या चॅनलला सबस्क्राईब करा आणि व्हिडिओ जर आवडला असेल तर नक्की लाईक करा. सो नाव वी विल स्टॉप हिअर ओनली. थँक्यू.